Alright, so we're going to do question 22 of 6b. Let's write it down here. Question 22 of 6b. And the question reads, to a person on a ship moving southeast at 25 kilometers per hour, the wind seems to come from the south with a speed of 15 kilometers an hour. Find the true velocity of the wind. Alright, so let's draw in our relative velocity equation. So we know the wind relative to the ship is going to be the true velocity of the wind. Take the true velocity of the ship. Now in the question, they've actually given us that guy and that guy. And now we're going to draw this in a diagram. Actually, before that, let's move around and let's make our true velocity of the wind our subject. So I'm going to move the velocity of the speed over to my left hand side. Let's do that now. So we got the velocity of the wind there, we got the velocity of the wind relative to the ship, and I'm going to add my velocity of the ship. So these are all vectors here, so I can draw that now in a nice little diagram. Let me show you. Right, so you're going to draw that in there like so. Draw one of these. There we go, just like that. And we're going to start with the wind relative to the ship. So I'm going to draw this one in orange so you can see it. Alright, so it's to a person on a ship. Sorry, we'll draw that in orange, and we'll draw the velocity of the ship in purple. So to a person on a ship moving southeast at 25 kilometers an hour. That's southeast, so that's going to be, that's south there, that's east. We're going to go this way, exactly southeast. That's going to be 25 kilometers an hour. The wind seems to come from the south with a speed of 15 kilometers per hour. So from the south. So if it's coming from south, it's actually going towards north. So don't get confused by that wording there. Okay. So it's coming from south, which means it's going towards north. So we're going to go tip to tail, and we're going to go south. And that's going to be 15. Alright, so we got two vectors there. So our resultant, we can use blue. It's going to be this guy there. Alright? So that's what we're trying to find. Well, first of all, what does that look like? Yes, it does look like a triangle, so we can use the cosine rule. We can in fact use the cosine rule to solve for my magnitude. We can use the cosine rule to solve for my magnitude of the velocity of the wind. So let's do that now. So we have the cosine rule here. Cosine rule. Alright, so the velocity of the wind squared is going to equal 25 squared plus 15 squared. Take 2 times 25 times 15 times cosine. Well, what angle is this? Hold on a second. Well, that's southeast and that's north. So this angle has to be 45, or halfway through a right angle. So it has to be cosine 45. Now we can solve for the magnitude of the velocity of the wind. You can use your class pad, or as they say, your handy dandy calculator, and you get 17.9 kilometers per hour. Alright, now we want to get the angle, or to find the bearing of the wind. Well, where's the direction? Now it's actually going this way. So the direction of this is actually going to come. There, that way. Let's go ahead and let's find that angle first. Okay, let's call that theta, as you do. Oh, go away. All right, so we've got an angle there. We got a known value. We got two known values there. Let's use the sine rule. Okay, I like the sine rule. It's nice and easy. Let's see. So we got sine theta over 15 equals sine 45 over our newly found magnitude of 17.9. Alright, let's solve for theta. You can use your class pad or your calculator, and here's what you'll get. You get 36.3 degrees. So that's not my bearing per se. Let's go back to my diagram. Well, that's 36.3, but I want to find my bearing has to be all the way there. So let's find where this line sits first. We'll go 45, take 36.3, and then we're going to plus 270, and then we get so that equals 278.7 degrees. Now we're going to round that to the nearest degree because of bearings, so we're going to get 279 as your bearing. So we have my magnitude and the bearing. Thank you.